Hello, my name is Robert Solomon and I'm a final year student and I'm going to be demonstrating my final year project. So the aim of my project was to investigate the protocols that were sent from an electric vehicle charging station to an electric vehicle. So here we have a full simulation of an electric vehicle connected to an electric vehicle charging station. So I'm just going to run this. So it's already running. So I'm putting in a voltage of 360 amps. I'll just hit charge. So here we see the sequence has begun charging. So it just passes on through the sequence, and here on the trace window we see the request and response messages that are sent over and back between the electric vehicle charging station and the electric vehicle itself. I'm going to be demonstrating these request and response messages that are sent over and back. So I will begin by demonstrating what I have done for the electric vehicle part of this presentation. Okay, so here's my robotic vehicle I've developed, which consists of many different parts that work together to produce the result. So the first part, it consists of a breadboard, ultrasonic sensor, Raspberry Pi, battery box, 2 chassis boards, 4 DC motors, and a motor controller and a battery box. So the battery box is placed here. Okay, so the way the ultrasonic sensor works, it has a transmitter inducer and a receiver inducer. The transmitter inducer sends out an ultrasonic wave which bounces off the object in front of it, and the reflected object is sent back to the receiver inducer. Then based off the algorithm I've implemented, you're able to get the distance of the object in front, and then it will give a warning to the user that it is too close to the object, and then it will find the best route forward. If it can't get out of the loop for maybe the third time, after the third warning, then it will just stop and break out of the loop. So deactivate. And then I've also tried to implement the line tracking, but due to some complications I wasn't able to fully implement it, but I've left some test scripts in case anyone wants to use it in the future. Okay, so now that I've explained the robotic vehicle and how that fits into the project, I'm going to be demonstrating the protocol sent between the electric vehicle and the charging station. So here we have the charging station running in Canoe, and that's listening in for a request coming in from the Python client. So here we can see some information being populated on the right window. And over here I've developed a C server and a Python client. The C server is using the OpenV2G library to listen for requests coming in from the Python client. So the Python client holds the parameters for each of the messages. So I'm just going to run that there. So here I've created a thread to start the battery loading sequence as the protocol sequence also begins. So here we see the C server producing an EXI data string for the messages. So this is what Canoe is supposed to understand, but unfortunately I wasn't able to match Vector Canoe simulation set of payloads. So I'm going to be using Packet Sender to demonstrate the sequence of how it should work. Okay, so I'm going to be using Packet Sender to demonstrate what was supposed to happen from my Raspberry Pi to the charging station. So the first message, which is the SDP request message, is sent over from the Raspberry Pi to the charging station. So here we can see the SECC discovery request message being called. So the EVSC processes this request message and populates a response to that message and sends back a response message. And then the next message, which is the supported app protocol message, sets up the electric vehicle and charging station for the charge sequence. So here we can actually see the schema that is being selected. So the charging station receives that request and populates a response, and then the session setup message is sent over. So here we can actually see the parameters being set, the session ID and the EVCC ID. So that again is being processed by the charging station, and then the charging station incorporates a response to that and then sends it to the electric vehicle, to my client. So here we can actually see the packets that are being received back from the charging station on this specific port number 511111. And then we get a OK response code, which is exactly what you're supposed to be getting. And then the next message, service discovery. Okay, we get a session ID, do not much. Okay, so we still get a service discovery request message, and then that's how the charging sequence will work. So it goes through all of the messages through the sequence. When it gets to the last request message, which is the session stop request, that's where the user can disconnect their vehicle and continue driving. So that's the end of my demonstration, which is to simulate the protocols sent from an electric vehicle station supply unit and an electric vehicle. Thank you very much for listening.